The visual system is mainly because of the eye, which again is not really made in order to function for a full lifetime. So it usually stops function probably around the age of 35, so just wait. At which time you get what is still called old man's eyesight, which essentially means that the ability of your muscles in the eye to change the curvature of the lens goes down, so the lens becomes rigid, and therefore almost all of us end up having to use glasses when we become a little bit older. Quite a lot of it is also because of degeneration in the retina and in the more central processing. So even though the eyes might be relatively well functioning, there's still a problem in actually paying sufficient attention and being sufficiently plastic later on in life. It also goes for the somatosensory senses. Just looking at the muscle spindles in the different muscles, it turns out that already at the age of 50, we have lost about 50% of the muscle spindles that we have at the age of 25. So it goes relatively quickly what that is concerned. And that, of course, influences proprioception. Proprioception, together with vestibular function, together with vision, are important for balance. So all of these things all go in the same direction towards problems with balance in elderly subjects. That is the one main problem that they have. This was the reduced proprioception, increased postural sway, all has to do with their balance problems. Another important thing, which is the main reason why elderly subjects or elderly people may have problems getting their driver license renewed, and the reason why they are sent to a doctor in order to see if they are fit to have a driver's license, is basically their reaction times. It's all about being able to step on the brakes sufficiently quickly in order not to run into the car which is right in front of you. So usually a 2-second period is what is required. So you need to at least keep a distance so that you can react, step on the brakes and make the car stop within 2 seconds. And that becomes a problem if you have reaction times which move towards half a second here, because the car and your muscles, etc., take up more or less the 1.5 second easily. And therefore, to sort of be able to avoid accidents, you should be well on this side of the half a second in order to avoid an accident. So again, what is the reason for this? Certainly bad eyesight is part of it, but the main reason for this increased reaction time is the central processing. It's simply that when you become older, you take more time in order to react to whatever sensory stimulus is out there. So it's not the motor function as such, so the efferent signal down to the muscle and the muscle contraction is sufficiently quick. It's all about the translation from, hey, there was something happening, I should do something, that is the real problem. Precisely where that is located and why this is happening, we don't really know, but that central processing is what we want to strengthen in the elderly subjects. There are lots of evidence now that one way of doing that is to have them play computer games. It's one of the most efficient ways actually to increase these reaction times, because computer games are all based on having some kind of sensory stimulus which you need to react to in an appropriate way. And you need to handle a complex environment with lots of different stimuli. So it has been shown now that a good way of preparing young people to have a driver's license eventually is to have them play a lot of computer games. It doesn't necessarily need to be computer games involving driving a car. It could be basically any computer game as long as it involves an analysis of a complex environment, lots of different stimuli, where you need to make a decision, what do you want to do next in order to react appropriately according to that environment. So it could be lots of different scenarios, just as long as you have that ability to cope with a lot of different stimuli at the same time. Yep. Yeah.
Nu siger du, at det er en god idé at få det på computerspil, men er det for eksempel at spille badminton eller nogle af de sportsgrene, som også kræver en vis reaktionstid?
It hasn't been sufficiently investigated, so I'm not able to give you a good answer to it. I know that the computer game part of it has been investigated, mainly because there's been a lot of pressure in order to see if it has any bad effects on young people doing so much computer gaming. And it turns out that there are no real negative effects. There are lots of positive effects. One of them is that they become much better at handling complex situations with a lot of different stimuli. It hasn't been tested in relation to badminton, but in general, for elderly subjects, the more active you are, the more socially well-functioning you are, the better you will also be functioning in relation to this. But is the causal effect now going in one way or the other? Is it so that because you have low reaction times, it's a sign that you have a good central processing, and therefore you also have sort of the energy to be socially active? So we don't really know if it's just because you're sort of being open and part of society that you then get a positive effect here. And it's difficult to really decide which way it goes. But there is an association, at least. So I think I will keep this for later on to discuss Alzheimer's disease, because this relates very much to memory, and therefore I think it's best to discuss Alzheimer's disease in relation to that. So basically, just to sum up, what I wanted to say is that we have this brain which really needs to develop quickly. It needs a lot of nutrients in order to do that. It's an amazing amount of development which takes place. The way it is being done is an interaction between genes and the environment. It's done by basically producing a lot of possibilities, a lot of networks which are then being pruned through interaction with the environment later on. And that process certainly goes on with the highest intensity during childhood and when we're teenagers, and then it sort of slows down, but it never stops. So we continue pruning, changing the networks throughout the rest of our lives. There are certainly degenerative changes coming on later on. We don't know whether in a completely healthy brain where there's no sign of Alzheimer's disease or any other diseases, whether we will actually see any loss of neurons, whether there is sort of a genetic programming which tells neurons to die eventually. Right now, I think most people will say that we can maybe theoretically live almost forever if we just make sure to not get sick and have all sorts of other diseases, degenerations affecting us. So I think I will stop there and